Video, we're going to talk about proportion and problem solving with rational equations. So first of all, solving a proportion, if we have a over b equal to c over d, solving a proportion is just a times d and b times c cross multiplication. So a times d equals b times c. So in the first one, 2 over 3 equals x over 6. We would do 2 times 6 and x times 3, so 3x equals 12. Divide by 3, x equals 4. Not going to spend a whole lot of time explaining proportions. This will just allow us to look at some applications to this and understand the process of solving, doing problem solving with rational equations, because there are some proportions that you need to solve. So here we're going to do 4 times x plus 3 equals 6 times x minus 3. So then I distribute the 4, distribute the 6. 4 times x is 4x. 4 times 3 is 12. Equals 6 times x is 6x. 6 times 3 is 18. Let me just solve the equation. So minus 4x, 12 equals 6x minus 4x is 2x. Minus 18. I'm going to add 18 over. So I get 30 equals 2x. Divided by 2, x equals 15. Alright, now let's start looking at some applications to this, some problem solving. It says the ratio of the weight of an object on Earth to the weight of the same object on Mars is 10 to 4. If a car weighs 3,000 pounds on Earth, find the car's weight on Mars. So we have a ratio that says the weight of an object on Earth to Mars is 10 to 4. So on Earth, 10 to 4. So Earth to Mars would be my setup, Earth to Mars. A car weighs 3,000 pounds, and we're trying to figure out how much it is on Mars. So when we're setting up that equal statement, so equal to some sort of ratio, we want to make sure if I set it up as 10 pounds on Earth to 4 pounds on Mars, I have to make sure I do 3,000 pounds on Earth to the X amount on Mars. So you have to make sure you're doing Earth over Mars, Earth over Mars. Like you can't do Earth over Mars and then Mars over Earth. You can't flip it around. So it's got to be Earth, Mars, Earth, Mars. And then we get this proportion that we just talked about how to solve that. So 10 times x is 10x equals 3,000 times 4 is 12,000. Divide by 10. And we get 1,200. So x equals 1,200. So on Mars, it will equal 1,200 pounds. Alright, cool. So first one done. Find the unknown length y in the following pair of similar triangles. So we have this side here, y, that's the unknown. And we have these triangles, and we want to figure out what is that length of y when they are similar triangles. So that means if they're similar, they're that proportion. So I can take side here and side here. So I'm going to set up this triangle. I'm going to call this triangle 1 and triangle 2. So that's 15 over 3.75. So now since I went triangle 1 over triangle 2, I have to use the same pair of sides going 1 to 2. So if I went 1 to 2, 15 over 3.75, that means I have to do then 23 over y. And the reason I'm choosing side 23 is because that's the equivalent side on this triangle. Like I wouldn't use 19 and y because those aren't the same sides. Like those aren't the same equivalent sides. So I did, so if I want to number them off too by side, so 1, 2, 3, 1, 2, 3. I did side 1 over 1 and 3 over 3. I kept them proportionate, used their equivalent sides. And then we get this proportion, we solve it, 15y equals 3.75 times 23 is 86.25. Divided by 15, y equals 5.75. So there we go, 5.75. All right, let's move on. So more problem solving. We have the quotient of a number in 6 minus 5/3 is the quotient of the number in 2. Find the number. So quotient indicates division of a number in 6. So the quotient of a number and 6. So I'm dividing some number that we don't know and 6 minus 5/3 is the quotient of the number in 2. So the quotient, again, is division of that same number that we don't know and 2. So, and then read it back. After you write it down, read it back. The quotient of a number in 6 minus 5/3 is the quotient of the number in 2. See how it directly just goes boom, 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 just sequences right together? That means I think we're on the right track. So then now we're solving this rational equation, just like the previous video, if you've watched the previous video. So just like the previous video, so now we are finding that LCD between 3, 2, and 6. The LCD is just going to be 6. So I'm going to multiply everything by 6. So I'm going to distribute the 6. So 6 times x over 6, 6 is canceled, left with x, minus 6 times 5/3. That's going to be 6 times 5/3. So you can do this 2 different ways. You can do 6 times 5, which is 30. 30 divided by 3 is 10. Or 3 goes into 3 once, 3 goes into 6 twice. 2 times 5 is 10. Either way, you get 10. X over 2 times 6. 6 over 2 is 3, so 3x. Now let's solve. I'm going to subtract x from both sides because I want to get the x's together. So negative 10 equals 3x minus x is 2x. Divide by 2, x equals negative 5. So there is the number, negative 5. Number 6, work problem. Sarah and Robert work in a factory that produces electronics. Sarah can complete an inspection of the production line in 4 hours, while her colleague Robert needs 6 hours to complete the same task. The factory supervisor is scheduled to visit, so both Sarah and Robert are instructed to complete the inspection together. How long will it take for them to finish if they work together? These work scenarios are hard at first because it's like, where do I even start? How do I write this down? So think of it in terms of like parts. If Sarah can complete the job in 4 hours, how much of the job does she get done in 1 hour? Think of it in terms of like an hour. So parts of the job. If it takes her total 4 hours, that means in 1 hour, she will get 1/4 of the task done. She'll go 1/4 of the task done in 1 hour. What about Robert? He needs 6 hours to complete the task. So how much will he get done in an hour? He'll get 1/6 of it done. And think of it like, how am I getting those numbers? Think of it this way. 1/4, if I add that up 4 times, what do I get? 4 over 4, which is 1. Here, 6 over 6. If I add that up 6 times, if I add up the hours that it takes. So 1 hour, he gets 1/6. 1 hour plus an hour plus an hour. So if you add up all these, you get 6 over 6. So you get that total of 6 hours. So in 1 hour, Sarah is completing 1/4 of the work. In 1 hour, Robert is completing 1/6 of the work. And then you put that together, it's going to take them some amount of time. So 1 over x. So let's just kind of spin on this. If this was 10 hours, it'd be 1/10. If this was 25 hours, it'd be 1/25 in 1 hour. So we're trying to think in terms of an hour. So now we're just going to solve this. So LCD is going to be 12x. I almost said 24. It's really easy to just do 6 times 4. You could do 24, but your numbers are going to be a little bit unnecessarily big. But we can do 12x, because 4 goes into 12, 6 goes into 12. So 12x. So I'm going to multiply everything by 12x. Distribute the 12x. So 12x times 1/4, 12 divided by 4 is 3, so 3x. Plus 12x times 1/6, 12 divided by 6 is 2, so 2x. Equals, x is canceled over here, 1 times 12 is 12. So 3x plus 2x is 5x, equal to 12. Divide by 5. X equals 12 over 5. So how long will it take them to complete the task? So 12 over 5 hours, if that doesn't make sense to you, like I don't know, like how long is 12 over 5 hours? I don't know. I would convert that to a decimal, so that means together it will take them 2.4 hours to work together. And look at your numbers and see if that makes sense. Like just make some sort of logical connection there. If Sarah does it by herself in 4 hours, Robert needs 6 hours. We know it's going to be faster than 4 hours for sure because Sarah on her own can do it in 4 hours. But then we have this slowpoke here, Robert, who needs 6 hours. But at least they're going to do it a little bit faster because Sarah can do it again in 4 hours. So whatever help she can get, it's going to go faster. So 2.4 hours. Sounds logical. Like if it was going to take longer, like if we got an answer like 8 hours, like that wouldn't make sense. Like why would two people doing one task take longer than either of them complete the task by themselves, you know? So just think about logic there. So 2.4 hours would be the answer. Sounds good. So again, we're thinking in terms of parts of the job. So this is in 1 hour, she'll get a fourth of the task done. In 1 hour, get a sixth of the task done. Because if you think of it, like, okay, if she takes 4 hours, in 1 hour she completes a fourth. 2 hours, she completes another fourth. 3 hours, she completes another fourth. And then 4th hour, she completes all of it. So then, for all those add up, 4 over 4, 100% of the task is done. So just trying to think logically there. Okay. Number 7, a bullet train travels 300 miles in the same time that a regular train travels 200 miles. If the bullet train speed is 30 miles per hour faster than regular trains, find the speed of the bullet train in the regular train. So the classic speed questions are always coming up. So let's set up a table. We have a bullet train, and we have just a regular train. The bullet train travels 300 miles in the same amount of time that the regular train travels 200 miles. So the distance for the bullet train is 300 miles. The regular train goes 200 miles. The bullet train speed is 30 miles per hour faster than the regular train, so we don't know how fast the regular train is going. So we're going to call that x. The bullet train, though, is going x plus 30. It's going 30 miles per hour faster than the regular train. So if the regular train is going 100 miles an hour, the bullet train is going 130. If the regular train is going 50, the bullet train is going 80. So we have that connection where it's just whatever that speed of the regular train is, the bullet train is going x plus 30. So now it does say the bullet train travels 300 miles in the same amount of time that the regular train travels 200 miles. So we know the time component is equal to one another. Here's how I want to manage this. If I have the formula equals distance equals rate times time, I don't know my time, but I can solve for time by dividing by r. So time is equal to distance over the rate. So I can take the distance of 300 over the rate of x plus 30. Same thing here, regular train, the distance of 200 over the rate of x. So I could just modify the distance formula in order to get the time component equal to distance over rate. So distance over rate, because distance equals rate times time, we solve for time. That means we're dividing by r. So time is equal to distance over rate. So then I have time. We know, as we just talked about, the times are the same, so they both travel for the same amount of time. The bullet train just went 300 miles and the regular train traveled 200 miles, but the times are the same. So since the times are the same, we set our times equal to one another. So 300 over x plus 30 is equal to 200 over x. Solve the proportion. This is why we talked about proportions at the beginning of this video. Solve the proportion. So it's going to be 300x equals 200 times x plus 30. And then distribute the 200. So 300x equals 200x plus 200 times 30 is going to be 6,000. Subtract over the 200x. 300 minus 200 is 100x equals 6,000. Divide by 100. I know I'm getting really close to my camera there. So we get x equal to 60. So x equals 60. What does that mean? It says find the speed of the bullet train and the regular train. So the regular train was going 60 miles an hour, while the bullet train was going 90 miles an hour. So we just take that x value, you plug it back in to our rates. So the bullet train was traveling 90 miles per hour. And then this one was going 60 miles per hour. Those distance questions are never going away. There's a lot of different strategies that you could take for solving these, but this is just one strategy. I think I got one more problem. Yeah, last problem for this video. A cyclist rode the first 22-mile portion of his workout at a constant speed. For the 18-mile cool-down portion of his workout, he reduced the speed by 2 miles per hour. Each portion of the workout took the same time. Find the cyclist's speed during the first portion and find the speed during the cool-down portion. So we have a distance equals rate times time problem again. What two components do we have? We have a workout component and a cool-down component. So we have like a first portion and a cool-down. So I'm just going to call this the workout part and then the cool-down part. It sounds like the distance for the workout portion was 22 miles. So he was at 22-mile distance, and then this person did an 18-mile cool-down. The rate, he says it reduced, is for the cool-down, for the 18-mile cool-down portion of his workout, he reduced his speed by 2 miles per hour. So in the cool-down, he went 2 miles per hour slower. So the rate for the workout portion was x, and then for the cooldown, went x minus 2. And you could flip that around by saying cooldown is x, and the workout portion would then be x plus 2, because the cooldown is slower, so you'd have to add 2 onto the workout. So there's 2 different ways that you could do that. And then, what does it say? It says each portion of the workout took the same time. So each portion took the same amount of time, meaning the times were equal. And then what we could do now is solve for time again. So here it is one more time. Distance equals rate times time. We need to solve for time. Time equals distance over rate. So time is 22 over x and 18 over x minus 2. Times are equal, according to the question. It says they took the same amount of time. So 22 over x equals 18 over x minus 2. Solve the proportion. So 22 times x minus 2, 18 times x. Distribute the 22. 22x minus 22 times 2 is 44. Equals 18x. Subtract 22x. So negative 44 equals 18 minus 22 is negative 4. So negative 4x. Divide by negative 4, and we get x is equal to positive 11. So x equals positive 11. Let's make sure we answer the question. Find the cyclist's speed during the first portion and his speed during the cooldown. So the workout portion is 11. That means the cooldown was 9. So not very fast for cycling. That's not working super hard, I don't think. Getting out workout. It's a nice long ride though, so maybe it's just because it's a long ride. 22 miles, 18 miles. Yeah, that's a pretty long ride, so it's probably hard to maintain a pretty fast speed going for that distance. But good workout though. Good problem. Good lesson.